Today I want to talk about reaction. I want to show you about how we can measure the rate of a chemical reaction. So the rate of a chemical reaction basically means how quickly that reaction is happening, okay? And the reaction we're going to look at today is a reaction between calcium carbonate and hydrochloric acid, okay? And these are the reactants. So we're going to start off with calcium carbonate, which is like marble chips, okay? And we're going to put the marble chips in the acid, and I'm going to know what the products of that reaction are. Now, in order to kind of try and come up with the products for ourselves, what we really want to do is look at what elements are present to begin with, because those same elements have got to be present at the end. You can't destroy atoms or create atoms. All they do is you break apart the bonds between some of them and reform some new bonds. Okay, so calcium carbonate has the formula CaCO3. Okay, this is a carbonate, anything that has a CO3 in it, so carbon and oxygen. And hydrochloric acid is actually a very simple formula. Hydrochloric acid uses hydrogen with chlorine. So to begin with, we've got 5 elements present. We've got calcium, we've got carbon, we've got oxygen, we've got hydrogen, and we've got chlorine. At the end, those same 5 elements will be present. So we can have a look at this and say, well, what are the products that are going to form likely to be? Okay, well, actually, a couple of them are very simple ones that you know about already. One of them is going to be carbon dioxide. Okay, remember carbon dioxide is CO2. Another one is going to be water, H2O. But obviously, there's 2 elements we haven't accounted for yet. We've got carbon, oxygen, and hydrogen on this side. 2 that we haven't yet got in are calcium and chlorine. Okay, so we're going to put calcium and chlorine together. Okay, CaCl2. Okay, and we call that calcium chloride. Okay. Now, when this reaction happens, then we're going to put the solid marble chips, the calcium carbonate, into the acid. It's going to produce carbon dioxide gas. It's going to produce water, which is just going to replace the acid in the solution, okay? And it's going to produce calcium chloride, which is what we call a salt, okay? And that's going to be dissolved in the solution, in the water, okay? Now, what we're going to do is we're going to use the carbon dioxide that's produced in this reaction to work out how quickly the reaction is happening. If the rate of reaction is high, we're going to get a lot of carbon dioxide produced in a short amount of time. If the rate of reaction is low, we're not going to get so much carbon dioxide. So we're looking at the fact that we've got a product, which is a gas being produced, okay? And we're going to measure the quantity or the volume of gas produced in a certain amount of time. And that volume of gas produced every second or every 10 seconds or every minute is going to give us an indication as to how quickly the reaction is going. Now, before I go any further though, I've got a bit of bad science on the board at the moment because I had a word equation, which is all correct. Calcium carbonate plus hydrochloric acid gives carbon dioxide, water and calcium chloride. But my symbol equation is not correct because it's not balanced. And as we look at it, you should be able to pick out which elements we've got a problem with. 1 calcium before, 1 calcium afterwards. That's fine. 1 carbon before, 1 carbon afterwards. That's fine. Okay. 3 oxygens before, 2 oxygens and 1 more oxygen, 3 oxygens after. So that's fine. 1 hydrogen before, 2 hydrogens afterwards. Okay. 1 chlorine before, 2 chlorines afterwards. Okay, so we haven't got enough hydrogen and chlorine to begin with. So what I really need here is to put a 2 in front of the HCl. Now I've got 2 hydrogens before and 2 hydrogens afterwards. Okay, I've got 2 chlorines before and I've got 2 chlorines afterwards. Okay, so we're going to carry out this experiment. I'm going to show you a couple of ways in which we can do the experiment. It's not just to do the experiment and see, oh yes, we've got carbon dioxide. We need to measure, okay, the quantity of gas that we produce in a certain amount of time in order to tell us about the rate of reaction. That's going to be the important thing here. The rate of reaction. Rate meaning how quickly it happens, okay? And when it comes to how quickly a reaction happens, you need to look at either how the reactants get less over time or the products get more. So obviously at the start of the experiment, we've got lots of calcium carbonate and lots of acid. As the reaction happens, you're going to get less and less and less calcium carbonate as it gets used up, and less acid as it gets used up, until eventually at least one of them will run out and the reaction will stop. Okay, so when the reaction stops, you're going to have none of at least one of your reactants. But the opposite is true with the products. To begin with, we've got no carbon dioxide. Okay, we've probably got some water because it's going to be a diluted acid. There's going to be some water in there anyway, but we're going to have no carbon dioxide and no calcium chloride. But as time goes by, we're going to get more and more of that carbon dioxide gas. So if we want to measure how quickly a reaction is happening, we need to either look at how quickly we lose reactants or how quickly we gain products. In this case, because carbon dioxide is a gas that's being produced, it's actually an easy way to investigate how the rate of reaction changes, because we're going to collect the gas that's given off, and I'm going to show you how. So I'm just going to pause the video while I set this up, and then I'll restart again and we'll go through. Okay, so I'm going to show you the experiment then in which we can collect the carbon dioxide gas that's produced by the reaction between hydrochloric acid. Hydrochloric acid looks pretty much like water. Okay, it's hydrogen bonded to chlorine, and that is going to be reacting with calcium carbonate, which are marble chips, which hopefully you can just about see in here. Okay, so what I'm going to do first of all, normally we would try and make sure that we knew exactly what the ingredients we were putting in. So I would measure out a set value of marble chips. Okay, at the moment I'm not too worried, I just want to show you the setup, but I should have measuring cylinder available to measure out a set value of acid, so here, and I should have a balance to measure out a set mass of calcium carbonate. As I said, I'm not going to bother too much with that right now. Okay, I just want to show you the experiment. So I'm going to take my marble chips, I'm going to put them into this flask. Now this flask is like a conical flask you've seen before, but it's got a little hole with an arm coming out the side. We call it a side-armed flask. Now when I put the acid into this flask with the marble chips and the reaction starts, okay, it's going to produce carbon dioxide gas. That carbon dioxide gas is going to bubble up to the top and it's going to escape into the flask. Now if the top was open, the carbon dioxide gas would escape out into the atmosphere. Okay, top's not open, so the only way it can get out is through this side arm. Now I'm going to force it to go out exactly where I want. And where do I want it to go? I want it to go through this pipe into what we call a gas syringe. Now the gas syringe has got volume measurements on the side of it. Okay, now at the moment it's completely closed. Okay, and that means that it says there's 0 volume of gas inside it. But as the gas escapes out, the syringe will get pushed upwards, okay, by the gas that enters it, and it will tell me how much gas we've produced. Now what I'm going to be doing, okay, I'm going to use my stopwatch, which is my watch for today, okay, and I'm going to be looking every 10 seconds what is the volume of gas that I've produced. Okay, so after 10 seconds I look, I leave it another 10 seconds, I look, and what I can get from that is an idea of how much gas is produced in a certain amount of time. Now if I get more gas produced in a certain amount of time, I know the rate of reaction is high. That means the reaction is quickest. And generally what we find with reactions is they always start quicker. So as soon as I put the acid in, the reaction is going to happen very quickly, but over time, the rate of that reaction is going to get less and less because we're using up some of our reactants. We're going to have less calcium carbonate in there. We're going to have less acid in there as time goes by. So the reaction rate is going to get less. So this is called a gas syringe. Okay, we take the pipe on the other side of it and we put it over the arm of the side arm flask. I'll try and hold this up to you in a minute so you can see what's going on as it fills with gas. I need to place this somewhere you can see it. Okay, what I'll do is once I've put the acid in, I'll try and hold it up towards the camera so you can see it a bit better. So I'm going to add the acid. Okay, remember at the moment it says 0 on my gas syringe. We've got to be very careful with this. When I pour it in, okay, and obviously normally I'd be pouring in a set amount, so I'd be measuring it out in a measuring cylinder like this. What am I using? Probably too much, almost 40 there. I don't need that much, but I'm going to add it in. As soon as I add it in, I need to get this top on, because if I don't, okay, what we're going to find is a lot of the carbon dioxide is going to escape in the first few seconds. Okay, so I add it. I can already see, I don't know if you can see the bubbling from where you are, okay, on here. So we're definitely getting a gas produced, okay, and that gas is carbon dioxide. I look at my gas cylinder, okay, it's no longer on 0. And can you see that, sorry, the gas syringe is getting pushed up and up? So I forgot to start my timer actually, but I start it now. So after 10 seconds, how much would have been left? And after 20 and after 30, and we'll keep going. So this is going to tell me, okay, about how much gas is getting produced in a certain amount of time. Okay, now we should normally find at the start it goes up quickest, okay, and then as time goes by, the rate at which it increases gets slower and slower. So we're still going up. It looks like it's slowed down a bit to me. Now once it goes over the scale, can you see the scale on my gas syringe is 100? Once I go beyond that, I can't really take any more measurements. Okay, so once I get to here, really that's the end of my experiment. Now, if I wanted a longer period of time, then what I could do, I could use less calcium carbonate, less acid, or I could use a bigger gas cylinder. Okay, now once it's got to the top, okay, now there's nowhere for the gas to go, so I'm going to remove the top of my flask, just because otherwise the gas is building up in the syringe and there's possibility it could kind of pop the pipe off. Okay, so this is one way in which we can investigate the speed of a chemical reaction. Okay, now this way, like the next way I'm going to show you in a minute, only works if you get a gas produced. Obviously, if there was no gas produced in this experiment, I can't collect the gas. Okay, so this can only be used for those kind of reactions in which a gas is produced. I'm also going to show you in a moment a second way where you can do something very similar without using a gas syringe. Okay, so this gas syringe is one way in which I can collect gas, and the more gas I collect per second or per 10 seconds tells me the higher rate of reaction. I'm just going to pause the video for a minute and then I'm going to show you a second method for doing the same. Okay, so second experiment, very similar, exactly the same reaction. We're looking at calcium carbonate reacting with hydrochloric acid, so we're going to collect the carbon dioxide again. This time we're going to do it in a slightly different way. Now, I've got a tray of water in front of me, and I've got a little measuring cylinder which is completely full with water, okay, to the top. Now, what I need to do, okay, is I need to get it upside down while it's still full, and I'm going to clamp it upside down in this tray. Okay, so you can see that, I don't know how well you can see actually on the video, but the water level is pretty much completely full inside this measuring cylinder. So the water can't fall out because the top of the measuring cylinder is submerged in the water. If I lifted it a bit higher, all that water would fall out. But while the top of the measuring cylinder is down under the water, it can't fall out. Now what we're going to do is we're going to produce carbon dioxide gas in the reaction, and we're going to make it bubble into this measuring cylinder. Okay, so I'm going to use the same sidearm flask as I was earlier. Okay, when we produce the gas, it's going to bubble out the end of here. Notice I've not got it connected to the gas syringe anymore. I'm going to put this pipe underneath the measuring cylinder because there's a little gap between the bottom of the tray and the measuring cylinder, and the bubbles of carbon dioxide gas are going to come up and fill up the measuring cylinder. Okay, so I'm going to put this in front here. I'm going to take the pipe, I'm going to stick that pipe and make it go into the bottom of the measuring cylinder, and you can see some bubbles are already coming up. Now that's kind of an error in my experiment because that's the bubbles of air which have escaped. So I don't know how well you can see, but my measuring cylinder is now not completely full of water. There's some air in that. So I know I can look already on mine and see that there's almost 10 milliliters of air. Okay, that means I need to subtract that from the volume I collect. Now I'm going to start collecting gas, the same thing as last time. I should be recording the time at the same time, because if I want a rate of reaction, I want to know how quick it is. I need to know how much gas do we produce in 10 seconds, in 20 seconds, in 30 seconds, so on. Okay, now I haven't got enough hands at the moment to do all this. Ideally, I'd like someone to help me who's going to do the timing, and hopefully when you guys are next back in school, we can have a go at these experiments. You can do them for yourself. Okay, but I'm going to collect the gas inside this measuring cylinder, same as last time. I'm going to open up the sidearm flask and I'm going to put calcium carbonate chips inside it. What I want you guys to look for, okay, that's water in there. Let's get rid of that. What I want you guys to look for are the bubbles which are going to fill up this measuring cylinder. So, reaction starts. I should be starting my timer right now. Okay, we're getting bubbles inside the flask. Now, can you see we're getting bubbles passing up through this measuring cylinder, and the airspace at the top is getting bigger and bigger. Okay, so the bubbles are displacing the water and forcing the water downwards, and instead we're filling this up with carbon dioxide. So my space of carbon dioxide here is getting larger and larger and larger. Eventually, if there's enough carbon dioxide produced, it's going to force all the water out of the measuring cylinder and into the tray. And so what I can be doing is saying, after 10 seconds, I've got 50 milliliters. After 20 seconds, I've got 70 milliliters. You see, already I'm at 65, getting towards 70 milliliters now already. So we can see the bubbles escaping out of this pipe. But they're slowing down already, because we always get maximum rate of reaction at the start, and that reaction rate is going to slow down over time. So we're now at about 90 milliliters. Remember, once it goes off my scale, this is a 100 milliliter measuring cylinder, I can't take any more results. So right now it's just hit 100. That means that actually beyond that, my experiment doesn't really get me any results. Okay, so this is a second method then for measuring the rate of a reaction. Just like the first method, okay, it can only be used for reactions that produce a gas. This reaction produces carbon dioxide. Lots of reactions will produce other gases, hydrogen, oxygen, things like that as well. But some reactions don't. Now, we do have some methods for measuring the rate of reaction for experiments, for reactions that don't produce gases. And I'm going to attach to Google Classroom a sheet that's got 4 different examples of how you can measure rates of reaction. The 2 that I've just demonstrated for you are going to be on there, but I'll put 2 others as well. One looks at how the mass of the reactants changes over time. So you actually do the reaction on weighing scales and you see what happens over time to that. And another one involves change of color, okay? Because some reactions have a change of color, and you can actually use that to work out, give yourself an idea of the rate of reaction. So I just wanted to show you today then 2 examples that we can use to measure the speed of a reaction. You've got a task now which I would like you to do on Google Classroom. Okay, it involves you watching a couple of videos looking at collision theory. Now, collision theory is our kind of underlying theory for how chemical reactions occur, because it's all about particles colliding. If 2 particles don't collide, a reaction can't happen. So, for example, you've got your calcium carbonate particle, you've got your hydrochloric acid particle. If they never touch, there can't possibly be a reaction. They need to collide. They need to collide with sufficient energy to break bonds, okay, and in the correct orientation. We talked about this a couple of weeks ago as well. Now, if that happens, we can break the bonds between maybe the calcium and the carbonate, and we can break the bonds between the hydrogen and the chlorine, and then new bonds can form. And the key thing, a reaction like this, which is exothermic, means that less energy goes into breaking the bonds than you get back when the new bonds form. And so overall, it's giving you our energy, and it's giving you a new product. Remember, that's the key thing about any chemical reaction. A new product is formed, okay? So if you're not sure of anything, rewatch this video again. When you're done with that, okay, you've got some questions and a couple of videos to watch. All of the questions on the sheet are answered on the video, okay? So if you miss it the first time, go through it again, okay? And what I'd really like to do is, guys, get you guys back into the science lab so we can do some experiments yourself, because this is very, very practical. If we don't manage to get back this year, then a lot of what we're doing on chemical reactions is going to be covered again slightly differently in year 9, okay? Right, enjoy the rest of your day.